Hello there, Mr. Sutton here, bringing you the IM3 Chapter 1 Quiz 2 review solutions on elimination method and systems word problems. In general, to solve a system of equations using elimination, like they want us to do on this problem, we have to double check to make sure both equations are in standard form. That's ax plus by equals c form. We want the variables on the left and the constant on the right, so that when we add equations together, we can combine like terms. Now, in this system, we have that situation. We have both of these in standard form, so we don't have to move anything around. The next thing we check for, because we're eventually going to add equations together to get rid of a variable using elimination, we want to make sure that if I add these equations together, things are going to cancel out. And if I do add these, I've got a negative 7y and a positive 7y. I have opposite like terms, and those are going to cancel when I add these equations together. So my next step then is just to add these equations together. I'm just going to rewrite this first equation under the second one here, just so they're nice and lined up here. And now I'm just going to combine like terms. So adding these together, the 7y's are going to cancel. Negative 6x plus negative 5x gives us a negative 11x on the left side. And on the right side, 4 plus 29 is 33. Dividing both sides by negative 11 to get x by itself, we have x equals negative 3. Once I've got the value of x, I just go back and plug this in for x in any of the equations that I started with. I'm going to use this equation over here just because I've got more space over here. So plugging in negative 3 for that x, we have negative 5 times negative 3 minus 7y equals 29. So that's going to be 15 minus 7y on the left. Subtracting 15, we've got 14 on the right side. And careful, because you still have this negative next to the 7. So then dividing by negative 7 to get y by itself, we have y equals negative 2. And then just writing out the point for my final answer, we've got negative 3, comma, negative 2. To solve this system of equations with elimination, we have to first make sure both equations are in standard form. The second equation is in what we call standard form. That's ax plus by equals c form. For the first equation, though, to get that form, I have to add x to the left side here. So x plus 12y equals 17 is more in line with what we're looking for. And I'm just going to label that this is step 1, just so people can follow my work. All right. For my next step, in order to use elimination, we eventually have to add equations together to cancel out one of the variables. If I do that right now, then I'm going to get 3x plus 18y equals 33, which doesn't help me at all. I need things to cancel out when I add equations together. So to get that, I'm going to multiply one of my equations by a number that's going to give me opposite like terms. So it looks like the easiest way to do this, I mean, it's half a dozen of one, 6 of the other, literally. You could multiply this first equation by negative 2. That would give you a negative 2x, which would cancel out this positive 2x. Alternatively, you could multiply this second equation by negative 2. That would give you a negative 12y, which would cancel out the positive 12y here. So I guess just pick a direction and go with it. I decided to multiply this first one by negative 2, but there certainly were other ways to do this. So that gives me negative 2x minus 24y equals negative 34. So just make sure you're multiplying this whole equation by negative 2, because you can't just change one piece without changing everything here. So now adding these two equations together, and I'm going to label that this is step 3, just again to make it easier to follow my work. These two x's are going to cancel. 6y minus 24y, or plus negative 24y, is negative 18y. And 16 minus 34, that's going to be negative 18. Dividing by negative 18, we see that y equals 1. And now I'll just plug in 1 for y over here, seems like a good place. And that'll give me the value of x. So I've got x plus 12 times 1 equals 17. So basically we have 12 here. Subtract that from both sides, and we get x equals 5. So then our answer, 5, 1. On this problem, we have Stacy with $3.80 worth of coins, quarters and nickels only. She's got 28 coins. We want to know how many of each type of coin she has. So we're going to start by defining variables for the things we're solving for. We've got number of nickels and number of quarters. I'm going to represent the number of nickels by n, And then Q I will use to represent the number of quarters. And we're going to set up some equations that will help us solve for these quantities. Now, one equation we can set up, since we have 28 coins, we know that the number of nickels, N, plus the number of quarters, Q, has to equal the total number of coins, which is 28. So that's one equation we can use. We can also set up another equation talking about the value of the coins. And I need another equation because there's a whole lot of things that add up to 28. So I need something else to narrow this down some more. So we can say that the value of all the nickels, that's 5 cents times the number of nickels, N, so 5 times N, plus the value of all the quarters, that'll be plus 25 times Q. That should add up to this $3.80, which I'm going to write as 380 just to have it all in terms of cents rather than dollars. At this point, I can use either substitution or elimination to solve this system. If you go the substitution route, you have to isolate N or Q by subtracting the other one in this first equation. But I chose to go with elimination, and I'm actually going to just eliminate the N's here. So to do that, I need to multiply this first equation by -5. That will give me -5N. That will allow me to eliminate the N's. And I'll also have -5Q equals whatever -5 times 28 is. That's going to be -140. Adding these equations together now, my N's cancel just like I wanted. And 25Q plus -5Q is 20Q. On the right side, 380 plus -140 is 240. And now just dividing both sides by 20 to get the value of Q, that's going to be 12. 12 quarters. Now that we've discovered we have 12 quarters, I can plug 12 back in for Q in one of these equations. Probably this is a good one to use here. So we have N plus 12 equals 28. And now if I subtract 12, I discover that I have 16 nickels. On this problem, we have the senior class at Awesome High School planning some trips to Canopy Lake. They rented and filled 10 vans and 9 buses with 320 students. And then Bogus High School, sounds like a great place to go. They had 5 vans and 7 buses with 210 students. We just want to know how many students there are in each van and each bus, assuming that there's no empty seats and that they all hold the same number of students. Each van holds the same number, each bus holds the same number. So let's start with some variables to define what we're trying to solve for here. I'll say that V represents the number of students in a van, and B, the number of students in a bus. And I can set up 2 equations based on the situation. So we have 10 vans filled with V students per van. That's 10V. If I add to that the 9 buses, each filled with B students, so that's 9B. If I add those 2 things together, the number of students in vans plus the number of students in buses, that should add up to that 320 that represents the number of students from Awesome High School that went on this trip. And I can do the same thing with the Bogus High School students. That would be 5V plus 7B equals 210. And now I just have to solve this system. Probably the easiest way to do this is by using elimination. It's going to be kind of tough to isolate any of the variables for substitution. With elimination, all I have to do is multiply this second equation by -2, and that will give me a -10V that I can turn around and cancel out with this positive 10V if I add the equations together. So we've also got a -14B, and this is going to equal a -420. Adding those equations together, 10V's cancel. 9B plus -14B is -5B. And then 320 plus -420 is going to be -100. Dividing both sides by 5, we discover that there are 20 students per bus. And now I can plug that back into, let's just use this equation over here because I've got space. And that'll help me find the number of students in a van. So we have 5V plus 7 times 20 equals 210. So that's 140. And if we subtract that from both sides, we have 70 on the right side. Dividing by 5, we see that there are going to be 14 students per van.